In 1959, at a secret proving ground, engineers and military command were awaiting the demonstration of a new development. A machine rolled out of the hangar that was radically different from any armored vehicle in the world. It was Object 279. Designers gave it a flattened, streamlined hull that resembled a spacecraft and outfitted it with a unique running gear featuring 4 tracks instead of the usual 2. The turret was shaped like a flattened hemisphere. The aim of this project was to create a combat unit capable of operating during a nuclear conflict and remaining combat-ready even after a massive explosion. To understand why such a tank appeared, it is worth looking at the geopolitical context of the mid-20th century. The Cold War was gaining momentum, and the United States and the Soviet Union were rapidly increasing their nuclear arsenals. By the mid-50s, both superpowers possessed not only strategic bombs to destroy cities, but also tactical nuclear weapons for use directly on the battlefield. American industry had developed nuclear artillery and atomic shells compatible with standard howitzers. The arsenals were stocked with nuclear mines, torpedoes, and even portable charges. Soviet strategists realized that in the event of a major war in Europe, the enemy would use their entire available arsenal against advancing columns. The military doctrine of the time assigned heavy tanks the role of a battering ram, intended to break through fortified defensive lines and open the way for the main forces. However, existing models, including the T-10 heavy tank, proved vulnerable in the conditions of atomic warfare. The shockwave could flip a multi-ton vehicle, thermal radiation damaged the optics and blinded the crew, and penetrating radiation posed a deadly threat to the tankers even through thick armor. After the explosion, the landscape turned into a so-called nuclear desert, pitted with craters, piled with debris, and blanketed in radioactive dust that made it impossible for standard armored vehicles to move. In 1956, the main armor directorate of the Soviet Army laid out new requirements for a heavy tank of the future. The specs called for a machine that could not only survive direct hits from enemy shells, but also remain combat-ready after a close-range nuclear blast. The tank had to negotiate difficult terrain, specifically areas ravaged by atomic bombs, while packing enough firepower to destroy any target. Meeting these demands seemed incredibly difficult, so the leadership announced a competition among 3 top design bureaus. 2 projects were underway at the Kirov plant in Leningrad, and a third at the Chelyabinsk tractor plant, famous for mass-producing T-34 tanks during the war. The design bureau, led by Kotin, was working on Object 277, while Isakov's team in Chelyabinsk was designing Object 770. But the most radical proposal came from the team of a Leningrad engineer named Lev Troyanov. The designer aimed to break free from established technical norms. Instead of upgrading existing designs like the other engineers, Troyanov decided to build something fundamentally new. He understood that simply adding more armor or engine power wouldn't be enough to solve the problem, so he started the design process by completely reimagining the very concept of a combat vehicle. The main threat during a nuclear explosion was the shockwave, expanding from the epicenter with devastating force. A conventional tank with its angular hull and high silhouette was a vulnerable target. The wave would slam into the flat armor surfaces and flip the vehicle over. Troyanov proposed giving the hull a maximally streamlined shape so the airflow would wrap around it without damaging the structure. That is how the distinctive configuration of Object 279 came to be, resembling a flying saucer or a seashell. Another major innovation concerned the running gear. The standard 2-track scheme had a significant flaw. When moving over rough terrain, the vehicle risked getting high-centered on a stump, a rock, or the edge of a crater. On ground covered in craters and debris, this would lead to the loss of the tank. The designer decided to equip the tank with 4 tracks, placing them in pairs on each side. This layout made getting high-centered impossible and ensured exceptional cross-country capability on any terrain. By 1957, the team under Troyanov's leadership had prepared the design, and 2 years later, the only prototype of this machine appeared. When engineers at the Kirov plant first saw the blueprints for the running gear, many were skeptical. Using 4 tracks instead of 2 seemed like unjustified over-engineering that would only complicate the design and make field repairs harder. However, the developers' calculations left no room for doubt. On each side of the tank, there was a unit of 2 track drives mounted on special longitudinal beams. These beams didn't just serve as load-bearing structural elements, they also functioned as fuel tanks. This engineering solution allowed the developers to save space inside the hull while ensuring the vehicle had a significant range. Each track unit consisted of 6 dual road wheels, without rubber tires, and 3 return rollers. The designers placed the drive sprockets at the rear, in line with the classic approach of that school of tank building. The absence of rubber on the road wheels might have seemed like a step backward, given the global standard of using it to smooth out the ride. However, chief designer Troyanov was focused on nuclear combat conditions. Since temperatures near the epicenter of an atomic blast reach critical levels, rubber would inevitably burn or melt, which would lead to a loss of mobility. Steel wheels, on the other hand, could withstand extreme heat and remain functional even after passing through a blast zone. But the defining technical feature of Object 279 was its suspension system. The developers abandoned the traditional torsion bar layout in favor of hydropneumatic suspension, which was considered cutting-edge technology at the time. Its operation was based on compressing gas in special cylinders, where nitrogen acted as the spring element and oil flowing through calibrated ports dampened the vibrations. This system allowed the tank to move smoothly over uneven terrain, maintaining stability even on broken ground. The combination of 4 tracks and hydropneumatic suspension gave the machine unique operational capabilities. The tank could traverse deep snow, thick mud, and swampy terrain, areas that remained inaccessible to conventional vehicles. The vehicle powered through blast craters, crossing fallen trees and the ruins of buildings. The absence of the usual clearance between the tracks ruled out the possibility of getting hung up on obstacles. The machine couldn't get stuck on a stump or a rock, simply because there was no open space underneath for such objects to get trapped. To get this 60-ton structure moving, a powerful power plant was required. The developers chose between 2 versions of a 16-cylinder, 4-stroke diesel engine, producing 950 and 1,000 horsepower. Both engines featured a horizontal cylinder layout, which allowed engineers to lower the engine compartment and give the vehicle a more squat silhouette. This factor played a key role in protection against shockwaves. The lower the machine, the less surface area was exposed to the destructive blast. The engine allowed the tank to reach a top speed of 31 to 34 miles per hour on the highway. For a machine weighing 60 tons, that was considered quite impressive. With a range of 155 to 186 miles, this combat unit could carry out deep raids into the enemy rear without refueling. While these numbers might look modest by modern standards, for a heavy tank in the 1950s, such specs were outstanding. Instead of a traditional manual transmission, the designers equipped Object 279 with a single-stream hydromechanical gearbox. The system automatically shifted the top 2 gears, which made the driver's job much easier and reduced the risk of mistakes during battle. Operating this transmission took less physical effort, so the driver didn't get as tired and could stay focused longer under pressure. However, these technical advantages came with a significantly more complex design. Using 4 tracks doubled the number of components and mechanisms that required maintenance. The hydropneumatic suspension turned out to be a difficult system to manage, calling for specially trained technicians and specific equipment. In the field, the crew had almost no way to swap out a damaged suspension part, so even with relatively minor damage to the running gear, the vehicle needed factory repair. Test drivers also noted increased power loss when moving over soft ground. The 4 narrow tracks created more resistance than 2 wide ones, so a portion of the engine's power was simply wasted. On top of that, the tank had poor maneuverability, making it more vulnerable in close combat since the machine couldn't turn on the spot or quickly change direction. Were offset by the machine's key advantage, its exceptional survivability. Troyanov designed the tank so the crew could withstand a close-range nuclear explosion and continue executing combat missions. Thanks to its streamlined hull, low silhouette, and lack of protruding parts, Object 279 remained resistant to a powerful shockwave. The vehicle was intended to lead tank breakthroughs and breach defenses even under conditions of nuclear warfare. While the running gear featured unconventional engineering solutions, the armor protection had no equal in the world at that time. Troyanov aimed to create a tank that existing anti-tank weapons could not defeat, and the designer successfully realized this vision. The vehicle's hull consisted of a cast assembly made up of 4 massive steel sections, all welded together. This casting technology allowed for complex, curved shapes that were simply impossible to achieve with rolled armor plates. The designers meticulously calculated every curve and angle to ensure maximum shell deflection. Striking the rounded surface at a sharp angle, an armor-piercing shell wouldn't penetrate the armor. Instead, it would slide off, losing its energy and deflecting away. However, the cast hull was only the first layer of protection. On top of it, engineers installed thin, curved steel screens that gave the tank a futuristic look. These screens served several purposes. First, they provided additional protection against shaped charges. Upon impact, a shaped charge munition forms a superheated metal jet that burns right through the metal. But if that jet encounters a thin screen, spaced apart from the main armor, the jet forms prematurely and dissipates before it can reach the target. Second, the screens gave the hull a streamlined shape, resembling a giant seashell or a disc-like object. This silhouette was considered optimal for counteracting the shockwave of a nuclear explosion. When hitting the rounded surface, the wave would flow smoothly around it, instead of transferring all its energy into a flat armor plate. Calculations showed that Object 279 could withstand the shockwave from a tactical nuclear warhead at a distance considered fatal for any other tank. As for armor thickness, the numbers remain impressive even decades later. The front of the hull featured about 10 to 10.6 inches of cast steel, sloped at effective angles. The sides were protected by 7-inch armor. For comparison, the American M103 heavy tank of the same period had frontal armor of just 5 inches, while the British Conqueror had about 6 inches. Object 279's turret was shaped like a flattened hemisphere, which also provided high resistance to projectiles and shock waves. The front of the turret reached a record thickness of 12 inches at a 30-degree angle from the vertical. This meant the effective armor thickness, taking the impact angle into account, was even greater. The rear of the turret had slightly less protection, but even that exceeded the frontal armor of most tanks of the time. This level of armor guaranteed protection against any tank gun existing in the world at that moment. Neither the 120mm guns of American tanks nor British weapons of similar caliber could penetrate the frontal profile of Object 279 at any combat range. Even the side armor could withstand hits from most anti-tank weapons. The vehicle remained virtually invulnerable in a classic tank battle. Protection against shaped charge projectiles deserves special mention. By the 1950s, shaped charge munitions had become a significant challenge for tank designers. They didn't require high muzzle velocity and could penetrate armor several times the thickness of the shell's caliber. Anti-tank grenade launchers equipped with shaped charge warheads turned infantry into a threat to armor. However, Object 279's protective shields reliably safeguarded the vehicle. Tests demonstrated that the tank could withstand hits from 90mm heat rounds at any distance. Remarkably, the designers achieved this high level of protection without using composite armor. Even though experiments with multi-layered structures, including ceramics and fiberglass, were already underway at the time, Troyanov achieved the necessary results using nothing but traditional steel. The effectiveness of this solution lay in the unique geometry of the hull. The engineers optimized its shape to deflect shells more effectively. The tank weighed in at 60 tons. For comparison, the Soviet T-10 weighed about 50 tons with weaker armor, while the American M103 came in at 57 tons. So, Object 279 was only slightly heavier than its contemporaries, yet it offered a qualitatively different level of safety. This design was the result of meticulous work optimizing every single component and detail of the machine. Beyond its passive armor, the tank featured an anti-nuclear protection system that sealed the hull and turret during a nuclear threat. Special seals closed off gaps and openings, preventing radioactive dust from getting inside. A filtration and ventilation unit purified the air supplied to the crew. This allowed the soldiers to fight in contaminated conditions while remaining safely inside the vehicle. Object 279's armor provided immense durability, but the developers designed the tank to do more than just take a hit. It was built for active combat. Engineers equipped the machine with one of the most powerful guns of its time. Its main armament was the 130mm rifled M65 cannon, developed for next-generation heavy tanks and self-propelled guns. This weapon was created in the late 1950s, drawing on a wealth of experience in artillery design. The barrel was about 23 feet long, and the gun itself weighed nearly 4 tons. This caliber allowed Object 279 to effectively counter other vehicles and destroy any armored target on the battlefield, while the M65's ballistic performance proved highly effective. An armor-piercing shell weighing about 66 pounds left the barrel at speeds of over 3,280 feet per second. At direct fire range, the kinetic energy of that round could punch through the armor of any tank in existence at the time. Armor of that era, like the M48, Centurion, or AMX-50, had no protection capable of withstanding a hit from a 130mm gun. This gave Object 279 the ability to engage targets long before they could get close enough to return effective fire. To improve accuracy, the gun was fitted with a slotted muzzle brake that absorbed a significant amount of recoil and stabilized the barrel. Engineers also included a system to purge the bore with compressed air. Since propellant gases remained after firing and could enter the fighting compartment when the breech opened, this forced air system vented them outside, keeping the atmosphere inside the vehicle breathable. The loading process was partially automated. Inside the turret, a semi-automatic cassette loader worked in tandem with the crew. The loader placed the shell and the propellant casing onto a special tray, and the mechanism then rammed them into the gun's chamber on its own. This setup ensured a rate of fire of 5 to 7 rounds per minute, which experts considered high for artillery of this caliber. At the same time, developers were working on a more advanced system capable of boosting the rate to 10 to 15 rounds per minute. But those plans never made it past the design documentation stage. The total ammunition load consisted of only 24 separate loading rounds. For a heavy tank, this was a small supply, but the tight layout of the fighting compartment made it impossible to store more ammo without lowering the crew's protection. Each round consisted of a projectile and a separate casing with a propellant charge, meaning the loader had to perform 2 operations instead of 1. However, the sheer power of the 130mm gun made up for the relatively small ammunition load, since it usually took just 1 direct hit to knock out an enemy tank. Secondary armament was provided by a 14.5mm KPVT machine gun paired with the main cannon. This weapon combined the rate of fire of a tank machine gun with the armor-piercing power of an anti-tank rifle. It was designed to engage lightly armored targets, such as armored personnel carriers and infantry fighting vehicles, as well as to take out firing positions and enemy troops behind light-filled fortifications. The machine gun carried a supply of 300 rounds. Additionally, the KPVT could be used as an anti-aircraft weapon to repel attacks from low-flying planes and helicopters. The heavy tank had a crew of 4. 3 were stationed in the turret: the vehicle commander, the gunner, and the loader. The 4th crew member, the driver, sat in the front center of the hull. That was also where his hatch for entering and exiting the vehicle was located. This layout was considered classic for heavy tanks of that era and ensured proper coordination of the crew in battle. To make the crew's job easier, Object 279 was fitted with the most advanced equipment of its time. A stereoscopic rangefinder sight allowed for accurate distance determination to the target without the need for ranging shots. It featured independent stabilization, which kept the line of sight steady even as the tank rocked while moving. The Groza dual-axis electro-hydraulic stabilizer kept the gun barrel locked on the target, regardless of the vehicle's rolling or jolting. This allowed for accurate fire on the move, giving it a significant edge in mobile combat. For night operations, the designers equipped the tank with a special sight paired with an infrared illuminator. An infrared spotlight flooded the area with light invisible to the naked eye, while the sight converted the reflection into a visible image. The effective night observation range reached several hundred meters, allowing the crew to spot and engage targets in total darkness. Most production tanks didn't get similar equipment until the late 60s, so this prototype was nearly a decade ahead of its time. The vehicle also featured an automatic fire suppression system that triggered if flames broke out inside, underwater driving gear for crossing riverbeds, and a heating system for the fighting compartment to operate in harsh winter conditions. By the spring of 1959, the development team had high hopes for the project. The only prototype ever built was sent to the proving grounds, where the machine had to prove its combat readiness. Testers ran the tank through rough terrain, forcing it over trenches and escarpments, pushing every system to the limit in the most difficult conditions. The powerful engine worked at its limit. The 4 tracks churned through the soil, and the 130mm cannon methodically struck targets downrange. However, the trials revealed a number of serious flaws, issues the engineers had suspected even during the design phase. The 4-track suspension turned out to be extremely difficult to maintain and repair. In the field, replacing a damaged road wheel or a broken track without special equipment was nearly impossible. Power loss when moving through soft ground exceeded calculations, and maneuverability remained poor. The tank turned slowly and clumsily. On top of that, the developers failed to lower the vehicle's overall height, and the complexity and high cost of production made mass manufacturing problematic. However, these flaws could have been ironed out during the refinement process. The industry certainly had the potential to handle such tasks, but the fate of Object 279 was ultimately not decided by engineers or the military. On July 22, 1960, a demonstration of the latest armored vehicles was held for the country's top leadership at the Kapustin Yar testing grounds. Nikita Khrushchev was presented with prototypes of heavy tanks, including Object 277, Object 770, and Object 279. The designers were counting on the head of state to appreciate their work and approve mass production. But Khrushchev had a different strategic vision. He prioritized missile technology, believing tanks were a less promising path for the future. After inspecting the vehicles, the first secretary forbade the military from adopting any tanks that weighed more than 37 tons. This order effectively halted all active heavy tank projects. Object 279, weighing in at 60 tons, did not meet these new restrictions. And so, the development story of this highly protected combat vehicle came to an end. The only unit ever built was transferred to the Tank Museum in Kubinka, where it remains to this day, standing out among the other exhibits with its unconventional appearance.